The Sun has just released a giant burst of plasma towards Earth. This is concerning because this is the same plasma that causes space weather events like solar flares and coronal mass ejections, which can damage important infrastructure here on Earth. But is this latest blast actually a cause for concern? You're watching this channel. Join me today as we look at the latest news, what it means for us here on Earth, and what you can do about it, if anything. We'll start out by looking at some footage of the actual event, before talking about what it all means. Then we'll finish off by talking about how you can protect yourself. Here's the footage. This is a time-lapse over 48 hours showing the Sun's surface. What you're seeing is a huge outburst of plasma. The plasma is glowing bright as it is superheated to over 1 million degrees Celsius. That's around 1.8 million degrees Fahrenheit. For reference, the surface of the Sun is only around 5,500 degrees Celsius, or 9,900 degrees Fahrenheit. So this plasma is really hot. This event was so big it was actually visible even with a homemade coronagraph. A coronagraph is an instrument used to observe the Sun's corona. The corona is the outermost layer of the Sun's atmosphere. These are pretty easy to make, and all you need is 2 pieces of paper and some aluminum foil. Let's see how it works. Take your 2 sheets of paper and punch a hole directly through the center of one of them. Place the second sheet of paper on the ground facing the Sun, and place the first sheet of paper with the hole in it behind the first sheet. What's happening is you're allowing light from the Sun to pass through the hole in the paper and onto the second sheet of paper. This will create a small dark disk in the middle of the image. This dark disk is the Sun's corona. The reason why it's dark is because the corona is significantly dimmer than the photosphere of the Sun. The photosphere is the layer of the Sun that we actually see when we look at it here on Earth. If we keep our coronagraph pointed at the Sun over the next few days, we'll be able to see the results of this massive eruption as it passes in front of the Sun. It'll be interesting to see if it makes it all the way through the corona and ends up hitting the Earth. If it does, we could see some auroras here on Earth. So now that we know what happened, let's talk about what this means for us here on Earth. This is a topic that gets people very excited, but it also confuses a lot of people. So I want to spend some time making sure we cover everything clearly. The Sun sends plasma towards the Earth all the time. We call these plasma ejections coronal mass ejections, CMEs for short. Sometimes these CMEs hit the Earth, and sometimes they don't. When they do hit the Earth, we get things like beautiful auroras, but we also get geomagnetic storms. Geomagnetic storms can damage important infrastructure like our power grid system, our telecommunications, our satellites, and our GPS systems. These are serious events, and they can cause billions of dollars in damage. The biggest CME ever recorded happened in 1859, and it caused widespread telegraph systems to fail all around the world. People were even able to send telegraph messages for free by simply connecting 2 wires together, because the telegraph system was getting so much current through it. In modern times, we had a similar event in 2012 that was dubbed the February superstorm. If this had happened just a few days earlier, many people would have been without banking services for weeks to even months. So how do we measure the strength of these events? Well, we use something called a linear unipolar inductor or a sunspot number. These numbers range from 0 to hundreds or even thousands. The higher the number, the stronger the event. So with that in mind, let's talk about the latest event. This latest eruption had a sunspot number of 122. This isn't exceptionally high, especially compared to others we've seen in the past. So right now there's no need to be overly concerned. With that said, we do need to keep an eye on this one. Even though the sunspot number is not incredibly high, this eruption came from a very large and very complex sunspot. It's also being helped along by another sunspot. The 2 sunspots are working together to amplify the signal, and that's going to increase the speed of this CME. There are currently 3 CMEs heading towards the Earth. The first one has already passed the Earth. This was a glancing blow, and it didn't hit the Earth's magnetic field very hard. It did manage to cause a minor geomagnetic storm, but nothing major. There is another CME that's still out in space, and that one looks like it's going to miss the Earth as well. That one is going to go right by us. It's going to be close, but thankfully it looks like it's going to miss. That brings us to the third CME. This is the one that I think has the potential to cause problems for us. This CME is coming from the same eruption as the other two, but it seems to have taken a different path. This one took a bit of a boomerang shape, and right now it looks like it's going to head right for the Earth. So, what exactly will happen when this CME hits the Earth? Well, when it does hit the Earth, it'll interact with our magnetosphere. This will cause our magnetosphere to compress and shift. As our magnetosphere shifts, this will induce electrical currents in the ionosphere. These electrical currents will flow up and down the Earth's magnetic field lines. This will cause a magnetic crochet. This is the main driver of geomagnetic storms. When these magnetic fields are disturbed, they'll release energy. This energy will heat the upper atmosphere. The heated upper atmosphere will expand, causing drag on low Earth orbit satellites. This can deorbit some of them. These events also cause a lot of ionization in the upper atmosphere. All these ions in the atmosphere absorb radio energy, which causes radio blackouts. Radio blackouts can last for hours or even days. Geomagnetic storms can also cause problems with our telecommunications, our power grids, and our compasses. How bad will this be? That's the million-dollar question. Right now, the models aren't painting a worst-case scenario. The CME is expected to hit sometime between now and June 22nd. Keep in mind, this is still early. The models could change. What we know right now is that the CME is going to hit the Earth. What we don't know yet is how strong that impact will be. Here's what we do know. Auroras will be visible all the way down to the equator during this event. There is also a chance that we could experience a global EMP, an electromagnetic pulse. These are extremely rare, but they have happened before. There was one in 1859 and another one in 1921. These events usually happen when a CME completely overwhelms our magnetosphere. When this happens, it induces a massive electrical current in the Earth itself. This creates a self-sustaining electromagnetic field that radiates outwards from the Earth. This radiation knocks electrons loose in basically every conductor on the planet. Every single piece of electrical infrastructure becomes damaged. This can knock out power grids, it can damage satellites, it can damage transformers. It can even damage things as far away as Antarctica. I have a video where I talk about the Carrington flare of 1859. This was the largest solar flare ever recorded, and it caused widespread telegraphic disruption all around the world. Many people believe that if this happened today, it would cause the extinction of humanity. So you might be asking yourself, could this happen again? Well, yes, it could. Could it happen soon? Maybe. Don't worry too much about it, though. If it does happen, we will have some challenges, but we will recover. It's much more likely that we'll experience a regional EMP instead. A regional EMP is much smaller in scope, but it'll cause similar damage within the region that it affects. The good news is that a regional EMP would only affect a small portion of the population. The bad news is it could still cause significant damage to the electrical grid and our telecommunications. Let's hope for the best, but prepare for the worst. What should you do if there is a large geomagnetic storm? You should focus on protecting your most important assets. Make sure you have food, water, and any necessary medications on hand. You should also check on any elderly neighbors or family members. If the power goes out, these people may need some extra help. The best thing you can do right now is to make sure you have a backup method of communication. You should also make sure you have a way to charge your devices and backup batteries. If you have critical medical equipment that needs electricity, make sure you have a backup plan in place. Generators, solar power stations, and solar panels are all great options here. What are your thoughts on this latest eruption? Let me know down in the comments below. I'm curious to hear what you think. And if you enjoyed this video, make sure you subscribe. Also, please share this video with anyone you think it might help. Thanks for watching. This is the host. I'll see you next time.